So today we're going to talk about panspermia. So our agenda is, what is panspermia, the lithopanspermia, traditional panspermia theory, and finally soft panspermia, and then finally the evidence. So first of all, what is panspermia? So according to Professor Ana I. Gomez de Castro of the Complutense University of Madrid, panspermia is the theory that life originated in space, in spatial ices, and continuously distributed to the planets by comets and meteorites. So basically, the theory is that life originated in space instead of natively on the planet. So first of all, we take a look at the traditional lithopanspermic theory. This is specifically referring to the theory that life is transported across space on rocks. So in theory, sometimes when something collides with a planet that supports life, the debris formed is fast enough to escape the atmosphere and fly through space, carrying along with it organisms from the home planet. Of course, it's very difficult to survive in space. So only the hardier microbes or those burrowed inside of the rock can survive. So for example, if you're exposed, there's a lot of toxic radiation, and the vacuum of space itself is very harsh, and so if you're not properly protected, you'll be killed. The weaker specimens that cannot withstand as much pressure will also be killed. The ones that are properly shielded and also are hardy enough to survive the vast vacuum of space will survive. This is the theory. So this flying piece of debris, along with many other like it, then make impact with the new planet. These life-bearing space rocks then release these microbes onto the new planet, which populate them. So basically, life is transferred between different planets through other objects in space. So we also have pseudopanspermia, which is also known as soft panspermia. So it's different from lithopanspermia in that it argues that space rocks bring the necessary amino acids, sugars, and molecules to form RNA to new planets, as opposed to pre-existing life forms. So instead of carrying along life, it carries along the building blocks of life. So these are going to be hardier than actual living organisms because they're not alive. So these drop these building blocks of life onto the new planet, and over time, they begin to form new organisms. And now we look at evidence. What can say that exoplanet 21, it has life as a result of panspermia? So to determine this, we will need to consider its planetary neighbors. Since panspermia involves the transport of living beings, or at least their components, it would be more plausible that they would be successfully implemented into exoplanet 21 if they were close to it. So the planets around 21 would most likely need to have the presence of microbial life or chemical structures that can combine with others to form essential proteins. So exoplanet 21 must be close to other planets that have these building blocks of life or supports life already, in order to have a higher chance at perhaps having life be spread through panspermia. Here are my sources. Thank you.